Hey guys, in this one we are looking at solving quadratic inequalities. So if you are in my inequalities and simultaneous equations playlist, the video before this one was my GCSE quadratic inequalities video, in which I go over the basics in far more detail than I'm probably going to here. So I would recommend going back and watching that first. If you're not in the playlist, I'll put a link to it down below in the description box. So these bad boys aren't really that difficult, as long as you are happy as Larry at sketching quadratic graphs. If you can do that, all you then need to be able to do is interpret them. So we'll build up in difficulty as we go. Let's get cracking. Okay, so our first one here, 25x squared is greater than 5x. Now, one of the more subtleties with quadratic inequalities is we might be thinking, well, this is quite nice. We have a common factor of x on both sides. Surely we can just divide that away and it's no longer quadratic. You are not allowed to do that. In the past, we're probably all guilty of dividing a common x away in equations or whatever. But with inequalities, we've got two problems. X, or the variable, whatever it is, might be equal to 0, and you can't divide by 0. It's one of the greatest sins in maths, so we can't do that. Or the variable might be negative. Now, in an inequality, if you either divide or multiply by a negative number, it flips the direction of the inequality sign. So you cannot divide away variables when we're dealing with inequalities. So what we do instead, we do a cheeky bit of rearranging so that we have a 0 on one side. Now, it doesn't matter on which side. I would always try and aim for, though, a positive square term. I just prefer that term, personally, to be positive. So, here, my first move would be to subtract 5x. So we get 25x squared minus 5x is greater than 0. Now, we do have a common factor here that we can get rid of, and that is this factor of 5. You can happily divide constants away. If we divide 5 here, we know 5 is positive, so it doesn't do anything mental to the inequality. Similarly, you can divide away a negative constant, because we know it's negative, we would flip the direction of the sign. So, I'm going to divide 5 here, that's going to leave me with 5x squared minus x is greater than 0. Okay, so now what I'm going to do on the left, I'm going to factorize this quadratic. So, if we just think of this guy, 5x squared minus x, if we think of that guy as our f of x, let's set f of x equal to 0. So, if we do that, if we set f of x equal to 0, now the reason for this is it allows us to plot the function. So plot the graph of the function, which is then really useful to help us solve these guys. So, if we set f of x equal to 0, then we've got 5x squared minus x is equal to 0. And then if we factorize, we've got x lots of 5x minus 1 is equal to 0. So what this allows us to do now is find the solutions of the quadratic equal to 0, so the points where it crosses the x-axis. So this guy at the start tells us one of them is x equals 0, and the bracket, well, we set that equal to 0, so 5x minus 1 equals 0 leads us to x equals positive 1/5, like that. So what we can now do is just make a sketch of this graph. So we know passes through that point and some point over here. So this here is the point where x is 0. This over here is the point where x equals 1/5. So now that we've sketched our graph, we can work out what point is, or what range of points is, that we are interested in. So we want 25x squared minus 5x to be greater than 0. So that is asking us then, where is our graph above the x-axis? So we are interested in this point, or all of these points over here, and all of these points over here. So in terms of the x values here, we want it to be strictly greater than 0, so it's not allowed to be on the x-axis, it's not allowed to equal 0, it has to be greater. So over here we would want x is greater than 1/5, so that would produce this right hand tail of our parabola, or on the left hand side we would want x to be less than 0. So those are our two solutions to this quadratic inequality. We could write this in set notation too. We could write this then as x such that x is less than 0, or, so it's a union, x such that x is greater than 1/5. Good times. Okay, example 2. 2x squared minus 9 is less than 3x. So, first step, let's get everything on the same side, with a 0 on the other. So, let's move this 3x. So we're going to get 2x squared minus 3x minus 9 is less than 0, like that. So now if we set the quadratic equal to 0, factorize and solve, we can then sketch the graph. So 2x squared minus 3x minus 9 equals 0. Well, let's see, can we factorize that? We're going to need a 2x in one of the brackets and an x in the other. Now we need our two numbers at the end to multiply to 9, so that's either 1 and 9 or 3 and 3. Let's try 3 and 3. Now one of these needs to be positive and the other negative. So if we had 2x plus 3, that would give us 3x. And if we had x minus 3, minus 3 times 2x would give us minus 6x. So 3x minus 6x would give us that minus 3x in the middle that we need. So that is how it factorizes. So what does that give us for solutions? 2x plus 3 tells us x is minus 3 over 2, and x minus 3 tells us x equals positive 3. So we can now sketch this. So one of these values is negative, one is positive, so like something like that. So now we've got our graph, we can solve the inequality. So we wanted 2x squared minus 3x minus 9 to be less than 0. So in terms of the graph, less than 0 is down below the x-axis. So we're down here. So the range of x for that is, well, x is greater than minus 3 halves, but less than 3. Or in set, we can say x such that x is greater than minus 3 halves, and it's an intersection this time. X can satisfy both of them at the same time. X has to satisfy both of them at the same time. So, and x such that x is less than 3. Like that. Good times. Okay, example 3. 36 minus 4x squared is less than or equal to 0. So, first of all, this one, we've got a common factor that we can just divide away. That common factor is 4. So, this is the same as 9 minus x squared is less than or equal to 0. Now, as I've mentioned before, I always like to have a positive x squared term. So what I could do, I could multiply both sides by minus 1, change the direction of the sign. I could add x squared, take away 9, which is really doing exactly the same thing. I could do that, but in this one, I'm going to stick with a negative x squared term just to show you how we do it. So the answer is going to be exactly the same. It has to be. So 9 minus x squared is an example of a difference of 2 squares. So if we set 9 minus x squared equal to 0, you could even just add the x squared to both sides and square root for this one. But if we get on the factorizing route, we would get 3 plus x times 3 minus x is equal to 0. Now this would give us x equals minus 3, x equals positive 3. So now that we have our x-intercepts, we can sketch. So we got a negative x squared term, so it's an unhappy quadratic. So we know this point here is minus 3, this point here is positive 3. Now we can solve the inequality. We wanted 36 minus 4x squared less than or equal to 0. So that means on or below the x-axis. So we want this bit and we want this bit. So over here we've got x greater than or equal to 3, or over here x less than or equal to minus 3. So those are our two separate solutions in set. And we would write this as x such that x is less than or equal to minus 3. Union, so it's an or, x can't satisfy both of these at the same time, or x such that x greater than or equal to 3. Okay guys, I think that's enough fun for this video. So the big things to take away are collect everything on the same side, get a 0 on the other, set the function equal to 0, solve it, hopefully by factorising. If you can't factorise it, use another method, find your x-intercepts, sketch a graph, then interpret your graph to solve the inequality. Okay, take it easy guys.